This is the Leetcode problem, and the problem statement is the given we have given three integer a, b, and n, and we have to return the return basically maximum value of a jar x into b jar x, and here the x lie between the 0 to 2 power less than 2 power n, and since the number is too large, so product we cannot be stored in the integer. So here we basically we take the modulo modulo 10 per 9 plus 7. So basically and here in the jar basically the jar is the bitwise jar operation. So basically we have to maximize a jar x and b jar x. So the any for example any two number which have equal almost equal number, then the product become maximum. This is the intuition of that problem. For example, if we have number 4 we have number 5 and 5, then product will be 25, and if we number have 1 and n, then the product will be 9. So we try to basically maximize the we maximize the product, then we have to make the number a and b almost equal. So here the approach is that basically using jar, we when here we check which one is the minimum, we try to increase of that value. So here 5 a is equal to 12, b is equal to 5. So we try to increase the 5 using jar, bitwise jar. We and then after then we again check which one is the maximum. Again we try to maximize which one is minimum. So basically we are doing the bitwise using bitwise operation. So we convert the 5 into bits and 12 into bits. So basically so basically here the so if we have a is equal to 12 and b is equal to 5, then in bits number become in 12 in bit 110, in 12 number become 100, and in bits 5 become 0101. So and we also given n is equal to 4 in this problem. So we basically take the jar to the power n, almost to the power n. So here the maximum value of to the power n should be 1111. So basically we try to maximize the number which a and b, which one is minimum, we try to maximize of that number. So here 5 is minimum, so first we set the 0th bit, and here the last bit is 1 and here is the last bit 0. So the bits are different. So basically we basically uh, we we basically update the bits which have minimum value. Here the b is minimum, so we try to make the 0th bit should be 1, and if and here we take the here the ith in the x value, in the x value we take basically here bits are different, so we try to increase the value of b, so that's why we set here the 1. So basically we take the last bit of the x should be 1, so that the this 0 1 2 3 fourth 0 1 2 3 third bit should be 1 in the b, and increase the value of b. Now basically now 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 the number become changed, so we take the bitwise join in both, so a become a become 0 1 0 0, and b become 1 1 0 1, and now here the bits are 1, and now we basically we set the bit we set the bit in the in the second position. So here which one is the minimum? Here now a become minimum, the value of a is equal to 4, and the value of b become 13. So here both are, if both bits are same, then we have to nothing in both. If both bits are same, then we have to set the both bits should be 1 1. So here already 1 1, so we take here the in the x with 0. If here if the both bits are equal, then we ensure that bits should be 1 1 always. Either we take the 0 or 1 depending on the bits. So here already 1, so here we take the second bit in the x should be 0, so that job become 1 1. And now here also in the both a and b, both the first bit is same, so here we set to 1. So we take in the x the first bit should be 1, so that the first bit in a and b should be 1 after applying the job. And here bits are different, so here bits are different, then we check the which one is the minimum. So here minimum is a, here minimum is a, that is 4. So we try to set that bit should be 1, and this bit should be 0. So here we take the job bit with 1. So now the number become number become here here we take 1. So we take, so here we take the jar with number this 101, so number become we take the jar, then number become product of number become here 0 0 1, so number become product should be here the we take jar, then this bit should be 0, and so here a become 0 and this become 1, this 1 okay 1 minute. So now if the number become 0, here both bits are same, then 1 and 1, here number become 1, and both bits are same 1 and 0, and product of these numbers should be this number is equal to this is the this number is 7, and this number is 7 14. So the product of 7 and 14 should be what, 98. The now 7 into 14 should be 98. The answer of this is 98. So this is the approach of the problem. Now then the logic is basically simple. When logic is simple, basically if a, n and b, in the both a and b the ith bit is same, either 1 or 0, then we so that we set the ith bit should be 1. If already ith bit is already 1, then we in the x the ith bit should be 0, and if the ith bit is 0, then we take the ith bit in x should be 1, so that the both ith bit in a and b should be 1. And if bits are different in a and b, then we check which one is minimum. If a is minimum, then if a is minimum, then in ith bit the a in ith bit should be 1, and in ith bit in b should be 0. If b is minimum, then we try to set the ith bit 1 and in b, and the ith bit in a should be 0. So this is the approach, and we try to solve using basically simple approach. So here we are solution on this problem which I implement it. So this is the solution. Basically we make the solve function, and the solve function, and a and b, we pass a and b and the number of basically bits. So basically here we pass n, we pass n minus 1, so number of bits 0 1 0th, we take our 0th index, that's why we pass n minus 1. And when we try to first iterate rightmost bit, we try to iterate using rightmost, using right side, using left to right. So in the leftmost bit, we check if the we cross the if the bits are less than 0, that means basically we cross we iterate all the bits in a and b, so we basically return the answer. We take modulo a into b modulo, and we return the result. And we here the solution, and we basically we check here, we are checking the ith bit should be same or not. Here using right shift operator, we shift the index, and we take the and with 1. So if ith bit is set with that is 1, then this is the give, we take the and with 1, so give the 1, and if the ith bit is 0, then we give the 0 here. So that's why here we checking the both bits are equal or not. If both bits are equal, then we ensure that always in a and b should be ith bit should be 1. So here we take or, so that if ith bit is 0, then set to 1, otherwise if already 1, then here the 1 or 1 give always 1. So here we set 1 in always when both bits are equal, and returning the and bit and then solve the next I minus next bit, next bit. So and if both bits are different, then we checking here which one is minimum. So if a greater than b, in this problem we ensuring that always a should be always minimum. If a is greater than b, then we pass the b and a and index. Now in the next iteration a become minimum and b become maximum. So now here a should be minimum, and then we check the in the minimum value that is in a, the ith bit should be 0. If ith bit should be 0, then we try to set the ith bit in a should be 1. So that's why we take here the or operation and set to the ith bit should be 1. And here we basically we take the jar so that the ith bit in b should be 0, and then we call the next next for the we calculate same thing for the next bit. So this is the simple solution. And if we run a base solution, of course this is the simple version. Yeah, correct. We take the 98 98 930 12. So here giving 930 12. Yeah, correct. So we submit of this solution. Yeah, accepted.